Hello again. I want to introduce you to solving inequalities. We've talked about what inequalities are. We looked at the number line, remember? And a statement like 5 is greater than -2 is an inequality because these two things are not equal. And so we understand how that relates to the number line. 5 is just greater and farther to the right than -2, so 5 is a greater or larger number than -2, and that just states that. Sometimes we have to solve an inequality though, like we just solved equations. So I want you to see the difference, and it's just a little difference, but it's a really important difference, so watch me. You know how you can do something, any operation, if you just do it to both sides of an equation, because then they're both still equal? Well, you can do that with an inequality also, but you have to do it to both sides. So let's just kind of see how that is like solving equations and how it is different from solving equations. So let's take a look. If I decide that for some reason I just want to multiply both of these sides by 2, you know, I could do it the same thing to both sides. So I'm not trying to solve this yet. I just want to multiply by 2 and see if it matters. I'm just kind of investigating and checking this out. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. I could use any number. I just picked 2 out of the blue. Okay, so we've got 2 times 5 is 10, and this side we've got -2 times 2. And in case you needed to see your signs, negative times a positive is a negative, so that -2 times 2 would be -4. And now it says 10 is greater than -4, which is still true. So it is still true. So it is fine to multiply both sides of an inequality by a positive number. We just showed that it still gave us a true statement. All right, let's take the same one. Let's take our 5 is greater than -2. And this time, let's multiply both sides by a -3, let's say. I just want you to see what happens when we multiply by negatives. So let's multiply this side by a -3, and the same thing, this side by -3. So we go -3 times 5, we get -15 is greater than, now if you need to look at your signs, negative times a negative is positive. So we've got -2 times -3 is a +6. So now let's read what we have. We've now created this. -15 is greater than +6. I don't think so, and you don't either. So what we've come up with is not something that's true. So we're like, oh my, what are we going to do? We multiplied both sides by a positive number, and everything was fine. Not a problem in the world. But when we multiplied the inequality by a negative number, we did not get something that was true. So we need another step to make it true. So what we do is this. If we are going to multiply by a negative in an inequality, only in an inequality, then not only do we multiply both sides by the negative, but we take our inequality sign and we flip it the other way. Because if we do that, it will make it true every time. Because now let's read it. -15 is less than 6. Absolutely. 6 is greater than -15. Yes, right. So all we had to do was to ensure and to make sure that we still had something that was truthful. We just had to flip the sign. So there's a little rule that we say is if you multiply or divide by a negative, you need to flip that sign if it's an inequality. And other than that, there is no difference in solving an inequality and solving an equation. So let's work a couple, just a few, so I'm just introducing you to this. Okay, let's suppose that we've got -3w is less than 15. That's just a very simple problem. And we know that we should divide both sides by -3 because we've got to get that to go so we get w by itself. So we divide this side by -3, and we divide this side by -3. And we have to remember that when we divide by a negative, it's perfectly fine. We do it to both sides, but when we divide by a negative, we have to flip the sign. So that cancels with inverse property. We got 1w is greater than positive divided by negative, negative 5. So w is greater than negative 5. And that's the solution to the inequality. Okay, let's try another one. Let's take one like, let's say we've got 4x divided by negative 5, and let's say this time that is greater than or equal to, that's what it means if you have an equal sign down there. 4x divided by negative 5 is greater than or equal to 2, let's say. And this is a two-step problem, but you have the same issue. So you work it exactly like it's an equation, really and truly exactly, with the only exception being our rule. If we multiply or divide by a negative, we flip the sign. Otherwise, no difference. So we look at this and we've got 4 times x divided by negative 5. And we're like, well, what should we do first? And we know we do the 4 last. So we want to get rid of this number first. So we multiply the left side by negative 5. And then we multiply this side also by negative 5. So we have to do the same thing to both sides. So we did that so that our negative 5s would cancel with the inverse property, and that would give us 4x, and we're right on schedule to getting our x by itself. But because we multiplied by a negative, we have to flip this the other direction for it to be true. So now it says 4x is less than or equal to. And then 2 times negative 5 is negative 10. And then our last step, divide last. So we divide this side by 4 and this side by 4. I'm not dividing by negative, so I don't need to worry about flipping or anything. So divide by 4, inverse property, x is less than or equal to negative 10 fourths. And yes, I do need to reduce or simplify my answer. So I've got x is less than or equal to negative, and I've got 10 over 4, so I'm going to reduce it by 2. 2 into 10 goes 5, and 2 into 4 goes 2. So my solution turns out to be x is everything less than or equal to negative 5 over 2. So that is really all that we're going to do with inequalities. We'll do much more later in the next video, but I wanted to make sure that you had an introduction because you can take off from there. You just want to know that if you multiply or divide by a negative, you flip the sign. And that's it. Otherwise, there is absolutely no difference. So many more likenesses in comparing and contrasting solving equations, simple equations and simple inequalities. Many more likenesses than differences. So thanks for being with me today. I hope it's a great one for you. Go outside and run around, get some exercise, and I'll see you next time. Did it, that's all. Let me just focus it.